Hello everyone. Welcome to GraphQL in Space. Big thank you to dgraph for hosting this conference and for having me. This is a picture of the International Space Station, and it is absolutely incredible. Just take a look at the size of this thing. There are apparently 3 people living and working on it right now. And we know that it's too big for any spacecraft to deliver into orbit in one trip. So that means it had to be delivered in pieces, and then it had to be assembled in orbit. Could you imagine when those 2 central modules had to fit together for the first time and form that perfect seal and start communicating status to one another, start transferring electricity? It must have been an incredible moment. And that kind of integration challenge, as an engineering problem, software professionals face this kind of thing all the time. Now, they don't have to do it in space, but nonetheless, they face conceptually similar integration challenges. That's why I want to talk to you about full stack type safety with GraphQL. I'll be your host, Robert Zhu, and I'm a principal developer advocate for Amazon Web Services. Now, let's say that we're trying to integrate a client and a server. One of the most important considerations you can make about the client and the server is the protocol that they're going to use to communicate with one another. In many ways, the protocol is going to dictate the shape and the style of the client and the server. It can have deep implications for what kind of performance your application can achieve, how quickly it is to build new features. And just to give you a couple of examples, the protocol also operates at multiple different layers. At the lowest layer of abstraction, we might be dealing with UDP versus TCP. And as we move up the layers in terms of abstraction, we might be talking about HTTP request response, or maybe we're using a WebSocket. And even higher than that, we might be talking about the architectural style. Like, are we using REST or are we using GraphQL? Now, one really important aspect of protocols, and one aspect that I'm really happy to see a lot of development on over the last few years, is an emphasis on the type safety of the protocol. Now, what I mean by type safety is, let's say you have a server, and the server creates appointments for you. The client is trying to say, hey server, I'd like to create an appointment. Here's the start time and end time. As it sends those 2 pieces of information, how does it express that? Are those timestamps Unix epochs? Are they strings that follow the ISO 8601 datetime format? The client and the server have to agree, right? Because that's not a trivial difference. First off, just as a data type in any type-safe language, that's the difference between a string and a number. And the second thing is, even if it were a string, you have to kind of agree, like, what is the encoding of the string? Now, it's no coincidence that I call out type safety, and type safety happens to be one of the superpowers of GraphQL. So here's what an application of GraphQL might look like when you fill out those boxes. On the client, you might have a web application built with React. And on the server, you might have a GraphQL endpoint built with type GraphQL and Apollo server. And of course, tying together both of these components is your GraphQL schema, your definitive type system that spans the client and the server. Now, once you have a GraphQL schema, on the client, you can use a tool such as GraphQL code generator, and you can consume the schema to generate type-safe client bindings. And this can create a huge difference in the development experience as you build the application. It can create a totally different experience when you detect API breaking changes or when you add new features. And I want to show you how all this fits together in an end-to-end application that uses TypeScript and the following architecture. Here's the repo that we're going to use. feel free to clone this and follow along, or just read along and go through the code as I show you. All right, let's get into the code. Before we dive into the code, let me give you a quick tour of the application. It's a to-do list manager. I know, you've seen 1,000 of these. And I think the reason why we keep using these as examples is because you know what you're building feature-wise. It's just variations on what the tech stack looks like. So here we go. I can create a new list here. Let's say I want to build the International Space Station, and then I can add to-do items to this, like learn how to build solar panels, or find a rocket. That's going to be important. And then as I'm done with these, I can check them off, and then I can clear done. All right. Hopefully that's pretty self-explanatory as for what we're building. Now, as I was going through that though, you can probably infer that there were a couple different API calls going on between the client and the server. We built a list, for example, but in the very beginning of the application, we also loaded lists and existing lists, right? We added an item, we checked off an item, and then we cleared done items. So let's take a look at the GraphQL API, just to see how all these different API calls are structured. So here's GraphQL Playground. GraphQL Playground is one of the GraphQL IDEs. And with GraphQL Playground, we can author our GraphQL query in the left, hit play, and then we'll see the response come back in the right. But what we're really after is the schema. What does the schema look like for this particular application? And here it is. It's really simple. And whenever I open a schema, the first two things that I look for is the query type and the mutation type, because this tells me what is the system expressing in terms of its capabilities for reading data, and what is the system expressing in terms of its capabilities for mutating that data. All right. So with query, really simple. I've got all lists, and I can fetch a list of to-do lists. Okay. With mutations, I can add a list, I can add an item, I can set an item to done, and I can clear a done item. And these are all of the operations that we identified just kind of by analysis, right? Now, obviously we can do this with a really simple application, but with a more complicated application, it'll be hard to exactly correlate what you see happening on screen versus what GraphQL queries and mutations and subscriptions might be going on in the background. Nevertheless, always really, really important to take a look at your GraphQL schema. Now, the other thing I want to point out is, look at to-do item. To-do item has a breakdown in terms of the scalar fields that it supports and their types. For example, it's telling us name is of type string. And not only that, this exclamation means that it is a non-nullable string. Priority is of type float, and it is also non-nullable. And done is Boolean. Now, this is what I was talking about with respect to type safety and why GraphQL is so good at this. Because the schema definition language here is telling us unambiguously, if you ever get a to-do item out of the API, this is the structure and these are the types for all the scalar fields. That is incredibly powerful, and we'll see how to combine that shortly with GraphQL Code Generator to turn this into client-side static types. Okay, we've got our repo cloned, and I have it open here in VS Code. And what you should see when you clone the repo is two folders at the root, one called API, the other called dub. And these are two separate projects. Dub is just a folder containing the contents of create React app with the TypeScript argument. And then API is a Node.js project that is going to be running type GraphQL along with Apollo server, and of course, all built with TypeScript. Okay? Let's take a quick tour through each one so you can see how all this fits together. Starting with API. Okay, within API, let's go into the source folder and open up server.ts. This is our entry point. And what we can see here is there's not a lot going on. We're creating Apollo server here. We're listening on port 80. And we're building a schema to pass to Apollo server. Now, we only have a single resolver in this list of resolvers, this to-do list resolver, which means that all of those operations that we saw in the GraphQL schema must be defined within this one resolver. So if we navigate to the definition of the resolver, we can see that indeed, yeah, this is it. Not a lot of code. We have that one query, which lets us fetch all lists. And let's just take a look at this one. Remember, in the schema, we had a type query, and the query type contained a single root query, which was called all lists, and it returned a collection of to-do lists. Now, the way that we express that in code is just these 4 lines. We have this @query decorator, and this is a decorator that comes with the type GraphQL package. And what we're saying is that it returns a list of to-do lists. And then here's the function that runs, that backs the resolver. So this is a promise, and then it's going to call get all lists. And get all lists is just going to perform an async read from a file, basically. In this demo, it's really simple. In production, of course, you'd be backing this with some sort of database. Either way, it's going to be an async call, so this function is asynchronous. And then all of these are decorated with mutations, which means that this is what is causing those 4 root mutations to appear in the mutation type. Here you can see that we've got add list, add item, set item done, and clear done items. This is it. So now we have this one resolver file that almost looks a lot like the schema. And in fact, if you take a moment and familiarize yourself with this, you should be able to predict exactly what the schema is just by looking at the combination of resolvers. Now, that's it for the server, really. There's not much else to it. As you're playing around with this demo yourself, if you're wondering where the data is stored, that's going to be under the data directory under state.json. Not a whole lot going on there. I'll let you explore that on your own. So let's move on to the front-end React application. This is www. And again, we'll drill down into the source directory. Of course, index.tsx, our standard create React app entry point, just says, hey, look, we're going to render this one root element called app. That's going to be defined in app.tsx. And the potentially the most interesting thing going on here is this store provider. So this is how we're doing state management for this demo. We're using the use context React hook, which is a way to do really lightweight state management. I do not recommend you use this for larger applications, more complicated applications where a lot of data is changing. It's not that efficient at that scale. You probably want to reach for something like Redux or Relay even. But in this case, just for the purposes of this demo, the store use context hook pattern for React state management is sufficient. It's super simple. We have up here use effect, and all this is doing is it's replacing component did mount. Whenever the component has mounted, we just want to call store.refetch, and that will refetch all of the lists in the server. And down here we have pretty simple. We have a header, and we have a button to add these lists, to add new lists, and then we have a lists grid down here. All the other items I think are really simple. They're self-explanatory, so please feel free to explore them at your own pace as far as the React application goes. Now, the thing that makes this React application interesting is its integration with the GraphQL server. And to see how that works, let's open up the GraphQL folder. And let's take a look at a couple of these files. Probably the first one is this get all lists query. It's a .graphql file. And you can see up at the very top, we're defining a query called get all lists. And then we're just fetching the all lists root query field. And we're saying for each list inside this all lists field, we want to fill that out with this fragment. And a fragment is just a reusable snippet of GraphQL. But within the, when you use the combination of fragments with code generators, you get another quality, which is that the fragment becomes its own type. So it's a way to take a very large type that would have had all these fields and nested fields embedded in a single type, and to break it out and say, hey, that nested field that goes two levels deep, that's actually a separate type. And by defining these things as fragments, you get 2 separate TypeScript types generated out of these. So what we would see here is there's going to be something generated, a type generated just for full list details, and another type generated for full item details. And that's going to be really useful as you start to pass around these different parts of these documents that come back in your GraphQL response. Okay, so this is get all lists, and let's just go through one more .graphql file just to make sure that we see the different variations here. We'll look at add new item. Add new item is a mutation, And this takes in new item input, and it fetches a bunch of fields when you've added a new item. Pretty simple. And the way that you can do this is you don't have to write these .graphql files by hand. You can just author these right within GraphQL Playground. And then when you've got the query looking exactly as you want it, you can take the entire query and paste it into the .graphql file and then run code generator. Speaking of running code generator, let's take a look at that. I'm just going to open up embedded terminal within VS Code here, and then I'm just going to run npm run codegen. Now, whoops, I'm not in the right directory. That's why. So I need to be in www in order to run npm run codegen. And you can see that it's really fast because the server is running on localhost, and I've configured CodeGenerator to talk to the local GraphQL server, pull down that entire schema, and then generate the TypeScript types. So what it's actually doing is two steps. When it pulls down the GraphQL schema, it stores that in this graphql.schema.json file right here. And you can see that this is the JSON representation of that GraphQL schema, of the entire GraphQL schema. So that the file can actually get quite large. And I don't think a lot of people read this file manually, but you can. It does make sense. It's just a little bit verbose. But this is the schema. This is our serialized schema. Now, the second step that the GraphQL code generator is going to do is it's going to take a look at these GraphQL files. So let's say add new item, right? When it overlays this mutation .graphql file on top of the schema that we have, it's able to generate a type-safe TypeScript type. Because it knows, well, if you executed the add item mutation, then where you're getting back is a to-do item, and if you try and select these fields off of the to-do item, then we know the types of those items from the schema. And as a result, we can generate a type that exactly matches the structure and the shape of this .graphql file here. Okay? And that's exactly what it does. And when it does all of that, it dumps it all into this generated .tsx file right here. This is a generated file, and of course, GraphQL code generator can be configured to put this file wherever you want. Lots of different options, but we're not going to dive into that in this talk, though. You can take a look at the docs for that. But this generated file then, you can then go and create some really simple wrappers. One way you can integrate this is to integrate this directly within Apollo client, and you can basically use all these things as a higher order component. Or another technique that you can do is kind of like what I did right here, which is that you have a wrapper function around any particular function that you want, and then you can pull them out and use them outside of the context of a higher order component. And I think this offers a little bit of flexibility, but at the cost of, a little bit more typing. So that's it for the tour of the code and how these two projects fit together. Next, I want to show you what happens when you make a change to the server. So in other words, what does an API breaking change look like, and how does that affect your developer workflow? All right, last thing I want to show you is what the developer experience looks like when you have API breaking changes. And while it's desirable to avoid API breaking changes whenever possible, sometimes it's inevitable. And in order to simulate this, let's say that we've been gathering feedback from our users and they love the to-do list app, but they just want one addition, which is that we add the ability to specify the priority for a given to-do. That's really easy to do. You just come in here and you go into new item input. And remember, new item input is an input type that describes all of the input variables that we need to collect when we're creating a new item. Here we have list ID, name, and description. List ID being the ID of the parent list that this to-do item belongs to. So in order to add one more field to this input item, we can just follow this pattern here. Just grab one of the description fields here, and I'm just going to change this to priority, and then change the type to number. And then by virtue of having this TypeScript type annotation of number, type GraphQL is going to pick this up and say, this is something of type float. Now, what we've done here is that we've basically, by default, type GraphQL will say all the fields here are required. And if I wanted to make it optional, or in other words, nullable in GraphQL terminology, I can come in here and say nullable equals true. Now, if I did this, then that means that this is actually not a breaking change because prior versions of the client are sending the prior 3 fields. They don't include the priority field, but the server says that's okay. And again, in order to induce the error, we're going to make it work like this. And what this is going to do is say, anytime you try to create an item, you need to provide these 4 fields. But we have a web front end that is not providing 4 fields. So we should expect to see it fail. And it'll be interesting to see how exactly it fails and whether or not there are any important error messages that help point us along the way in terms of fixing this problem. So first, let's flip back over into our browser. And the first thing is I'm going to refresh GraphQL Playground. I'm going to pop open the schema. And right here on the new item input type, we can see that the change that we made is now live inside GraphQL Playground. It is now present in the schema, saying that anytime I get a new item input type, I have to have a field of type float called priority. So far, so good. Problem is that this client over here is not sending that priority field. Let's see what happens and how it breaks if it tries. So first thing is we're going to have a test list here, and now test item. Okay, didn't work. Unhandled rejection, error, network error, not responsive. So I think probably what we want to do is open up the network tab here. Try again. Okay, so we see that there is this one HTTP status code 400 in response to our post. And the response, I know the text might be a little bit small, but you can see here, hey, we got a bunch of errors here. It looks like there was one error, no data. And the error is message, variable input got invalid value, list ID, name, description, field value.priority of required type float was now provided. There we go. Now it makes sense. That's the exact error that we would expect, although we had to do a little bit of digging through the code in order to find it. And we can definitely change the front end to look for these network errors. We just don't have a lot of good error handling in place for this demo right now. But you can imagine, proper error handling means that you can bubble this up and make it much more visible, either through development or even in production. Okay? So, how do we fix this? All right. Well, back in the editor, we have that neat little Codegen function, right? We've updated the schema on the server, but the client thinks it's talking to an older version of the server. In order to resynchronize the client and the server so that they're talking about the same version of the schema, we just need to run Codegen. All right, Codegen succeeded. Now I can run TypeScript, compile. All right, so it says, TypeScript says property priority is missing in type, name string, etc. And we actually have to-do list view.tsx line 53. Let's go there. Here it is. Line 53. So if I add something like priority 5, and come down here, run TypeScript again. And my error has gone away. Okay, that's all it takes. And I want to point out that this is TypeScript catching this type error right now. This is not necessarily GraphQL. This is development time static type checking with the TypeScript bindings telling me, hey, this local TypeScript definition, this type definition, you're not meeting the constraints set by that type definition. Where did that type definition come from? It came from the Codegen process where we downloaded this schema from the server and then we paired it up with the local.graphql file definitions. And I know I'm trying to describe this same process in a number of different ways, but I think it's a really important concept to really understand in order to figure out what's going on here. Because if you take a development workflow like this into production, you definitely want to understand all the different ways that it can break, all the different integration points. But yeah, that's it in a nutshell. I think this is a pretty good developer experience. This is definitely a step up in terms of developer experience relative to a lot of REST APIs that I've worked with, where oftentimes the only way that you can detect whether or not this breaking change occurred is if you actually try and use the API, right? And then if there's some sort of minor API breaking change, well, all those handcrafted types are kind of outdated and you have no real way to update them. You can find an error, trial and error, oh, change this way, okay, go and update your local type definition, and then hope that works. And so I think because GraphQL includes this type system, you now have this end-to-end tooling that can enable this much more high confidence workflow, we'll call it. So hopefully that makes sense to you. If you want to take a look at the code, if something doesn't make sense, by all means, leave a comment in the repo and we can interact there. But that's all I have for you today. Thank you very much, and I hope you enjoy the rest of the conference. Goodbye.